You know how tech giants like Yahoo and Facebook deal with just oceans of data? Well, for a long time, the answer was a piece of tech named after a kid's stuffed yellow elephant. Seriously, this is the story of Hadoop, the framework that basically rewrote the rules for big data. So let's start with the problem Hadoop was born to solve, because it's really all about scale. As the internet just exploded, it became super clear that no single computer, I don't care how powerful it was, could handle the load. So what do you do? What do you do when your data just doesn't fit anymore? Well, we came up with a name for that challenge: big data. It's basically when the scale and the messiness of the data get so extreme that all your old tools just break. They can't keep up. Now, you've probably heard people throw around the 5 Vs. You've got the insane volume of data, the incredible velocity it's created at, and the huge variety of formats. Then there's veracity, how messy or clean the data is. But honestly, the most important V here is value. The whole point is to dig through all of that digital chaos to find the golden nuggets, the insights that can actually change things. And that's the exact problem Hadoop was built for. So to take on this massive problem, the world needed a totally new way of thinking. And the inspiration, of all places, came from a stuffed elephant. This is how Hadoop was born. No, I'm not kidding. It's absolutely true. The co-creator, Doug Cutting, literally named this world-changing technology after his son's favorite toy. It's just a great reminder that these huge, groundbreaking ideas can come from some really humble, really human places. And wow, did Hadoop grow up fast. It started out as part of a search engine project, but it very quickly showed what it was made of. By 2008, it broke a world record, sorting a whole terabyte of data in just over 3 minutes. Pretty good, right? Well, a year later, it did the exact same job in a mind-blowing 62 seconds. This wasn't a toy anymore. This thing was a beast. So what was the secret sauce? What was the big idea? It was actually brilliantly simple. Instead of spending a fortune on one giant, super powerful computer, why not just link together hundreds or even thousands of cheap, off-the-shelf computers and get them to work together as one single massive system? And this whole idea really rests on two main pillars, two core technologies. First up, let's talk about how it stores all that data. This is the Hadoop Distributed File System, or as you'll hear it called, HDFS. Okay, this is where you really see the difference in thinking. Your laptop or PC, its file system thinks in these tiny little 4 kilobyte chunks. HDFS, well, it's built for a totally different universe. It thinks in enormous 128 megabyte blocks. See, it's designed from the ground up to handle a smaller number of absolutely gigantic files, not millions of tiny ones. The best way to get your head around HDFS is to think of a library. You've got one master librarian, that's the name node. It keeps the master index, the card catalog. It doesn't hold any of the books itself, but it knows exactly which shelf every single page of every book is on. The data nodes, those are the bookshelves. They're the regular computers that actually store the data blocks, which you can think of as the individual pages of our giant book. Okay, so if Hadoop is built on all these cheap hardware that's expected to fail, how does it keep your precious data safe? The magic number is 3. By default, HDFS automatically makes 3 copies of every single data block and scatters them across different machines. So if one computer goes down, or even a whole rack of computers fails, no problem. Your data is still safe and sound. So that's how Hadoop stores these ridiculously huge files so reliably. But how does it actually process all that data? That brings us to its second superpower, this amazing processing framework called MapReduce. The strategy behind MapReduce is just so elegant and simple. Divide and conquer. Just don't even try to solve one gigantic problem on one machine. Instead, you break that problem into thousands of little tiny pieces. You solve all of those little pieces at the exact same time across your whole cluster of computers, and then you just gather up the results at the end. Think of it like a national census. You wouldn't send one single person to go knock on every door in the entire country, right? That would take forever. No, you send out thousands of census takers all at once. That's the map phase. Each worker, or computer, is processing a small piece of the data in parallel. Then later, you gather up all their clipboards and tally up the numbers into one final national count. That is the reduce phase. You're just aggregating all those intermediate answers into your one final result. So the whole process follows these 4 pretty clear steps. First, your input data gets split into chunks.
Then the map tasks all fire up at once, each one working on its own little chunk in parallel. Now, this next part is where the magic really is, the shuffle phase. It automatically sorts and groups all the outputs from the mappers. And finally, the reduce tasks take those sorted groups and combine them to give you that single final answer you were looking for.
Okay, so while HDFS for storage and MapReduce for processing are the absolute heart of Hadoop, they're not the whole story. An entire ecosystem of other tools grew up around them to make this whole big data thing even easier to handle. People often call this the Hadoop Zoo, and for good reason. See, writing raw MapReduce jobs is actually pretty complicated, so a whole bunch of other projects popped up to make life easier. You had tools like Hive and Pig, which let you analyze data using much simpler languages, so you didn't have to be a hardcore Java programmer. And then you had tools like Scoop and Flume, which were built to solve another huge headache, just getting all that data into Hadoop in the first place.
All right, let's wrap this up by just taking a step back and looking at the incredible legacy of this project. Hadoop really truly laid the groundwork for the entire modern big data world we live in today.
If you take just one thing away from all this, let it be this core formula right here. Hadoop's true genius was combining massively distributed storage with massively parallel processing. That simple but totally revolutionary idea is what unlocked the entire potential of big data.
You know, today, a lot of newer technologies have come along and built upon the ideas that Hadoop pioneered. It really kicked open the door to the data-driven world we all live in now. And that kind of leaves us with one final thought. What's the next big challenge? What's the next elephant in the room that's going to inspire the next great leap forward?